Hi, I'm Seema Kaheel,
Hi, my name's Gonzaga.
and this is our project on enhancing airflow dynamics and rainwater management techniques in urban environments through innovations and implications.
The transformation of landscapes through rapid urbanization is leading to the increase of impervious areas and disruption of natural water cycles, placing a strain on existing stormwater infrastructure and causing widespread flooding and pollution. Innovative stormwater management methods that leverage the relationship between airflow dynamics and rainwater techniques are essential to address these issues effectively. Traditional methods are proven inadequate. The integration of green infrastructure encourages natural water processes and lessens the reliance on conventional drainage systems. The project's core mission is to investigate new strategies for managing airflow and rainwater in urban areas, scrutinize current methods, evaluate environmental impacts, and pinpoint areas for future investigation. We acknowledge that we acknowledge that there are various challenges, including the variance in strategy effectiveness across different urban contexts, potential technological infrastructures, and regulatory hurdles.
Understanding airflow dynamics is crucial for predicting stormwater movement and dispersion in urban environments. This knowledge enables urban planners and engineers to develop strategies that optimize airflow patterns and reduce the impact of storms on infrastructure. Strategic urban planning elements like properly placed vegetation, building orientation, and street layouts can significantly enhance airflow and reduce heat accumulation. These changes in turn affect how rainwater is managed and distributed. Employing rainwater harvesting techniques, which involve collecting and storing rainwater from surfaces like rooftops, mitigates urban runoff and lessens the dependence on traditional water supply systems, particularly during peak storm events. The stored water can then be used for various non-potable purposes, contributing to sustainable urban management by easing the burden on urban drainage systems and helping prevent floods and water pollution. Moreover, incorporating green infrastructure and sustainable design practices into urban planning improves the urban microclimate.
Incorporating strategic urban layouts, such as aligning streets to promote wind flow and choosing building placements for natural air circulation, allows urban planners to enhance the microclimates of city environments and increase the prevalence of heat islands. Additionally, refined architectural elements, including aerodynamic building exteriors and strategically positioned windows, can direct airflow, shield structures from precipitation, and manage water flow, mitigating the accumulation of rainwater on surfaces. By embracing the concept of green infrastructure, urban landscapes can benefit from the integration of natural components like parkland greenery and eco-friendly rooftops. These features serve to improve air quality and regulate stormwater, promoting a more sustainable interaction between nature and the built environment.
Urban development has advanced to include smart ventilation systems that intelligently manage airflow in buildings, adapting to varying environmental and internal conditions to enhance energy efficiency and maintain optimal indoor air quality. These high-tech systems automatically regulate based on factors like carbon dioxide levels and humidity. Additionally, comprehensive strategies for controlling and utilizing rainwater employ innovative approaches such as modular detention systems and retention basins, which aim to mitigate urban flooding and repurpose water for sustainable use. Cutting-edge rainwater harvesting mechanisms are designed to capture and use precipitation efficiently, thereby supporting sustainable urban living. This effort is further complemented by the use of permeable surfaces and rooftop gardens that facilitate natural water filtration and retention, contributing to energy conservation and reduced metropolitan heat. Integrated water management systems represent a fusion of stormwater control, waste treatment, and water conservation practices, ensuring that the urban water cycle is managed sustainably and is scalable with growth and preserves ecological integrity.
For our first case study, uh, we'll be studying the Rotterdam. In Rotterdam, the city's cutting-edge water squares ingeniously serve a dual purpose. They are vibrant community spaces for recreation when the weather is clear and transform into efficient rainwater storage systems during downpours, effectively managing the challenges of excess water in a flood-prone region. The thoughtful design of these spaces incorporates strategic depressions and basins that capture stormwater significantly significantly easing the load on the city's drainage systems and allowing for the gradual release of water or its absorption back into the earth to recharge aquifers. Beyond their practical function in stormwater management, the the water squares enhance the urban environment by improving air quality, fostering biodiversity, and providing inviting communal areas for residents, exemplifying the multifaceted advantages of sustainable urban design. Rotterdam's strategy established a scalable and transferable blueprint for cities worldwide, signaling a paradigm shift towards integrated community-focused infrastructure that prioritizes sustainability and urban resilience.
For our second case study, in the city of Singapore, Singapore's urban planning strategy adaptly captures sea breezes to naturally cool the city and enhance air quality, marking it as a hallmark of its climate-smart urban layout. Architectural ingenuity is evident throughout the incorporation of sky terraces and verdant walls across its building aimed to dissipating the urban heat island effect. The city's dedication to sustainability is further shown by its expansive parks and water features, which are integral to its master plan and help regulate the urban temperature. This focus on green infrastructure bolsters public health by improving air circulation, thereby reducing reliance on air conditioning and enhancing energy efficiency. Complementing these efforts, Singapore's commitment to environmental stewardship is reflected in its proactive policies, with continual updates to building regulations to optimize natural ventilation positioning as our natural ventilation positioning it as a paragon of sustainable practices for tropical metropolises.
With these improvements, sorry, with these improvements, there come a various challenges. So we have prepared a challenge assessment. Some of the challenges in airflow enhancement is implementing airflow optimization is often hindered by the inflexible structure of existing urban landscapes, including densely built areas and historical layouts. Costly architectural modifications are also one of them. Architectural changes to improve airflow and water management bring about increased design complexity and higher costs, which can be prohibitive, especially in less affluent areas. Sophisticated small ventilation and water harvesting systems are expensive and complex, requiring precise data and maintenance, and are challenging to retrofit in older buildings. Green infrastructure, while beneficial for the environment, is constrained by the availability of urban space, climate adaptability issues, and maintenance costs, particularly in water-scarce regions. Comprehensive water management systems demand significant planning, investment, and community support, often facing political and regulatory challenges that complicate implementation. Thank you for listening to our presentation.